All right, we are now recording. Welcome everybody to the Network Plumbing Working Group meeting for March 15th, 2018. So if you take a look at the agenda doc, it's mostly, I did a few spec updates, not too much. I have an item at the end about a question I had with those updates, and then also Doug has been working on implementing the spec in the Multis CNI project, and he has a number of questions and issues with implementation that he'd like to bring up and talk about. So to kick off, I reworked Doug's text to formalize both the network selection annotation formats, which is what we agreed on at the last meeting, that we would try to support both. One question that I did have for that was, are people okay with using the same annotation name for both formats, or should we change the annotation so you can either specify the simple format and or the extended format, but they would have different annotation names? It might make it a little easier for plugins to work with. I don't have a strong feeling either way.
I could go either way too, although there is some merit to having annotation name for either format, just in terms of error handling for the meta plugin. So I'd be open to that as well.
I'd be open to it if we don't spend all day bike shedding the names of the two annotations.
Fair enough.
Yeah, fair enough. We've kind of been putting off that naming anyway for the moment. Okay, well, if nobody has any thoughts right off the bat, I mean, the only ones that I had were networks and then like network list or something like that. I mean, I guess they're both lists, but.
Network config for the advanced format.
I mean, look, here it goes, right? I mean, if you're going to name things, you know, if you have two different names for the same thing with slightly different formats, the difference in the name should indicate that it's a difference in format, not that it's a different thing.
We could do extended networks, for example.
I'm second on that because so currently the meta plugin also are the default network. So these annotation is the all for secondary network. So I think
But that was not his point, right? Both annotations would be for sidecar networks. My concern was that they shouldn't be like two different ways of saying the same thing. They should indicate in the names the difference between the two different ways of listing your sidecar networks.
Yeah. But I guess the real question is it that big of an issue for plugins to try to parse the format for both of them? I know it's probably not in Go. It wouldn't be that big of a deal in Go to parse that. But for other languages, maybe it is. But I don't know. I think my general feeling is it's probably easy enough to parse. It's just a question of clarity in the spec.
Yeah, I think it's easy to parse. Like, I would prefer keeping the same thing. Like, that was my original suggestion. So I don't mind just keeping one thing and move on.
Okay.
It may be easier for the user too, that it's just always the same name, and then they can chuck whatever they want in that field.
All right, fair enough. I mean, that sounds fine to me. So we'll go with that. We'll keep the same annotation name. The next thing that I added was I realized there was a gap in how we were talking about IP request and MAC request, and that there was no way in the specification, or the specification didn't say anything about how those actually got sent to the CNI plugins. So I added a section there. The only gap that we have is that there is no way currently to pass a MAC address into any of the CNI plugins. Well, let me correct that. There is a way to do it, but none of the plugins currently implement that way. Anybody could implement that in their own plugin. So there's that outstanding question. You know, we could implement that in the CNI reference plugins, and it probably wouldn't be that hard to do. So be aware of that. The way that this would get passed down to the CNI plugins that I identified would be through the conventions document. And that's the way that IP address requests are currently passed down to the plugins anyway. So it seemed like MAC request could go the same route. And there's some text in the document about that and a link to the CNI conventions document. The last question about that was that there is no way currently that plugins implement to indicate that they can actually handle the IP and MAC requests. So you would essentially be sending those into the void currently, unless you knew that the plugin that you were specifying actually supported those. And so what that would probably require is an update to the conventions document, or we could also define a de facto capability for CNI plugins to say that they could do this, and that would probably be fine to carry through to CNI officially. Is this issue unclear to anybody? I can go into a little bit more detail before I hand over to Doug.
Yeah, I wouldn't mind knowing a little bit more.
Okay. Yeah, sure. So, I mean, as we've defined it, we want to at least allow plugins to, or excuse me, allow users to request specific IP addresses and MAC addresses for the network attachments. And the way that happens is it gets passed through the CNI JSON configuration through the args parameter in the JSON configuration. But there is no corresponding capability that a CNI plugin advertises to say that it actually supports that.
Right. Like my question was like, what's the issue if we shoot it into void? Like that was my question. So what if you do it and it doesn't support it? Like what
well,
happens?
if it doesn't support it, currently plugins that don't understand the IP and
Right.
request stuff would just assign a different IP address, and that seems like the wrong expectation. I feel like if the user requests a specific MAC or IP address, that the plugin should either allocate that address or assign it to that network, or it should fail.
Okay, got it. Makes sense.
Yep.
Yeah.
And again, it is only a convention. So the way that this would theoretically be solved is that if you know that the network plugin that you are implementing that will be called by the meta plugin does support this feature, then you would add that capability to the configuration, or excuse me, to the JSON that lives in etc CNI net.d for your plugin. Or something like that. Most of this is described in the conventions document. And then, of course, you'd update your plugin to actually respect that and look at that argument in its config. The only missing bit there then is to add to this specification that the meta plugin should look at capabilities that are in the JSON of each config or config list before it actually runs that network attachment. And if that plugin does not support IP or MAC requests, then it should fail that attachment. So does that make more sense, Suresh?
Yeah, it does. Like, but it's only half the problem, right? Like, because let's say my plugin does understand, but it's like unable to allocate this address, like, or unable to assign this address. Like, that's another error as well, right? That we need to handle.
Yeah,
so
exactly.
Right now, okay, cool. Okay, so this, as long as there's like, it's not a 2-state thing, it's like a 3-state thing, I'm okay.
Yeah, and I mean, the way that I had sort of worked around it now in the specification was that the meta plugins should ensure that the requested IP and MAC is actually returned in the result structure from that config when it actually executes that config, which is kind of an icky workaround because it adds more code to the meta plugins that we probably don't want. And of course, that would happen after that attachment had actually been run. You'd done all the work, you'd allocated everything.
Excellent.
And so that works, but I think we'd rather have that check happen up front before we actually call any of the attachment stuff.
Right.
But
that's how. Yeah. Go ahead.
This is a 2-state thing. This capability is a yes/no capability, not a yes/no maybe. The issue of not being able to assign the requested address is always present and has to be handled differently. That would be handled as an error returned from the plugin after it's invoked.
Correct.
Right. Like, so my point was this, right? Like, so anyway, I need to go and check the result to see if my requested address got assigned or not, right? So like, why don't I just check it and be done with it? Why would I check for the capability? That was really my question. So
yeah, I mean, that is valid. You can always do that. It just seems like more code, and we'd prefer probably to trust that the meta plugin and the other plugin just does the right thing. And then you wouldn't have to do all this validation on the final result.
Okay, but I still have to handle the runtime errors, right? Like the
Yes. Yep. Yeah, I mean, at this point, at least the runtimes or the meta plugin probably would just take a look and say, okay, this chain returned an error, fail everything, and print some message somewhere, as opposed to, at least Kubernetes doesn't actually care that much about the errors. It just logs them.
Okay. No, I got it, Dan. And like, yeah, makes sense.
Okay.
Like, I do see it's like a simplification. Yeah, I just want to make sure that we're not doing extra step when one is not needed. But I understand, like, simplifying code somewhere else makes sense.
All right. So I will take an action item to update the specification to add that capability, and then we can probably reflect that through to the CNI conventions document as well. So at this point, I will turn it over to Doug.
All right, thanks, Dan. Yeah, as Dan mentioned, I've been working along with Tomofumi Hayashi on implementing the spec using Multis, going off the branch that Kral had started a while ago, and we've been able to implement a few things, and hopefully we'll demo that maybe the next meeting or somewhere around there, so you guys can kind of see like the spec in action. But as we've gone through that, a couple of questions have arisen for us, and anyways, I think these are kind of finer strokes, and I'm hoping that these aren't super difficult to work through. But here, why don't I just hit them up one by one? So the first one that I ran into is that the annotation name that we had penciled in there, it doesn't match what Kubernetes wants. So it's like domain name / v1 or / version / name networks, right? And Cube, when I went to implement that, Cube's like, hey, that's not what I want. I just want DNS name / thing. And so anyways, I was like, can we just drop the v1? I noticed that Dan added in here the idea of putting that version before cni.cncf.io. And I like that idea. I guess I would say maybe we could do like, instead of maybe alpha, beta, etc., maybe we could do just well, maybe that's not so bad, but if we did something like v numeral.cni.cncf.io, it'd make it easy for the meta plugin to scan through the like previous versions. So you could like put in it like, this is version 3, and I'm backwards compatible with versions 1, 2, and 3. That would be one idea, but anyways, I wanted to bring that up and see what people had to say about that particular version in the name and knowing the limitation of it now.
Nope. I mean, your point well taken. I had just penciled that stuff in, and you've obviously found that it doesn't work. So I'm perfectly happy to change that.
Cool. Yeah. So I'm happy to update the spec with that as well. With the numeral, for example. If anyone has any other input, that's awesome. Otherwise, I'll move on to my next topic too.
Okay, so I had just typed into the, CNCF. Okay, so I just typed into the agenda. I assume that's what you're talking about. It would be kubernetes.v1.cni.cncf.io /networks.
Yeah, that looks awesome to me. That looks totally good.
Any other thoughts from anybody? Does that format look okay? All right, in the absence.
I'm okay.
Okay, awesome. All right, let's just go with that then, Doug.
All right, sweet. All right, this next one may be my own misunderstanding of something that I might have missed earlier along, but this is regarding the multiple uses of the same network attachment. So, if you had in there, Mac VLAN, Mac VLAN, for example, or flannel, comma flannel, right? So you say, I want to attach this twice. And I know Suresh had suggested the idea of, network attachment name at interface name. So like Mac VLAN at E5, for example. And I like that. And I don't see why we couldn't potentially support that. But, as I was going through and testing it, I was using Multis. I noticed that what Multis does is it basically generates a name. So it's like net 0, net 1, net 2, ... etc. And so, it's not exactly part of the CRD, but I was thinking that maybe we could update the language of the spec to basically say that, the meta plugin is expected to create a unique interface name with each attachment that comes along. Maybe unless otherwise specified, if we do, go forward with the attachment name at interface name format.
Yeah, I think that's probably pretty much required.
Yeah, makes sense, Doug. I like it too.
So that's, again, that's one half of the problem. The other half would be the issues that we've discussed before around CNI's uniqueness tuples and things like that, which would be solved by Suresh's suggestion for the moment.
Cool.
Are you, any thoughts on that, Mike, or anybody else? This would imply that each separate attachment to the same network would get a different interface in the container. And just to clarify, this does not prevent multiple IP addresses being returned in the same attachment.
So for those of us who are working with network interfaces, I think that's totally expected and normal. I don't remember where we were. I know we've had some concern that we don't necessarily have to want to pin this down to making a network interface.
So one question is that how do we deal with the cases where we have a user-space networking stack when there is no sort of kernel network interface to deal with?
I assume you mean DPDK or VPP?
Yeah. This is a really good point. So maybe the language should be updated to say, in the case that interface would be created, it's expected that it would create a unique name. Otherwise, yeah, there are cases where you may not need that interface name whatsoever.
Is there a recommend to create the uniqueness for the same network? Actually, sorry, I was on vacation for 8 weeks. I missed a lot of the discussion on this one, but I'd like to understand why we need to create the unique interface name for the same network, actually.
First off, remember we're talking about network attachments. And the whole issue comes up because some people have use cases for multiple attachments to the same network.
Okay. But in this case, we can add something like ETH2 or ETH3 or ETH4, right? So
that's the idea here.
Okay. Okay.
So I had a follow-up question on the case of not using a network interface. In the case of using DPDK or something like that, is there some other sort of thing that also needs a name?
Currently, there is a hack we having in the DPDK. We currently requires the interface name actually. So there is a lot of hack for the DPDK regarding that. But we need the interface name because if you have a pod which have like 3 or 4 DPDK interfaces, then we need a uniqueness there.
Yes, I would expect that. So actually, I think you're saying something which actually doesn't surprise me very much, which is even in the DPDK case, you actually do have a network interface. You just for management reasons and accountability and identification reasons, you just bypass it for most of the data path.
Yeah.
I mean, I guess the question that I have is there a case where we would not want to use different interfaces for two different attachments to the same network?
I don't have such a case.
The only use case I can think of is if you want to have bigger throughput, so you want to have two different interfaces because you've got some limitation in there, you clearly want to have different interfaces.
That's okay. He was asking for the opposite, where you want the same one network interface for two different attachments.
Yeah, I think that's what Peter said, that you want to eventually aggregate the attachments into one logical device. But I think that should be done on the container side because it's application.
Yeah, that's what I'm saying. Is I think that's the only case we would ever want is to let the container do it. The whole thing from my point of view is push all the network complexity into the container. If there's some crazy stuff it wants to do with having multiple network devices and doing DPDK on it, let the container worry about that.
Yeah.
Just set up the physical hardware for it. So CNI sets up the interfaces, but nothing beyond that happens.
Yeah, so I mean, we have this concept of bonding. The question is, does a container normally have the privilege or capability necessary to do the bonding?
There is a bonding interface if you see that it's a third-party CNI plugin actually. So for the bonding, it requires the interface name in order to create a link aggregation interface or something like bond0 or something.
Well, I think for the moment, let's just go with essentially what Doug has proposed and add some language to the specification saying that the meta plugin should ensure uniqueness of the interface name for each attachment. And then if people can come up with situations where the same interface would need to host multiple attachments, then we can update the spec either before we finalize it or in V2 or something. And I mean, you can always sort of work around it in your own plugin if you want to by somehow detecting that you want two attachments from this one invocation.
Yeah, I think it's a fair way to do it. I cannot think of any such like use case, like personally, like I've done a lot of crazy stuff, and usually either bond in one way or you sub interface it in some way, right? And then that's how you do it. So I don't see why that's required the other way.
I mean, the only thing I can think of is, maybe more SDN type interfaces or plugins that would use only one interface and multiple IP addresses, and each IP address comes with a different attachment. And then all of it is handled by, some kind of switch or vSwitch behind that interface. But at least I don't have a use case for that right now. So.
Yeah, still the vSwitch kind of has a bridge where the interfaces show up anyway, even in those SDN use cases. So if you look at OVS, it'll be still you'll see the interfaces. So yeah, as I say, okay, if somebody has that, let them propose it. Let's how I would put it, right? I'm sure if somebody needs it, they're gonna scream.
Yep, that works for me. Does that work for everybody else? And by that I mean go with the language about uniqueness of interfaces per attachment, and then we'll see if anybody screams later.
I have a question about your comment, Dan, regarding the uniqueness problem, where CNI has the limitation that network name plus container ID is, determines the uniqueness. So certain CNIs may support multiple attachment where others don't. So how do we eventually solve this problem?
It could be theoretically solved by adding interface name into the CNI spec as a third part of the uniqueness. I did bring that up in the CNI maintainers meeting, and most of them were kind of ambivalent. So, I mean, we could continue to try to push that. The only issue is that the current plugins that are out there are only required to use the container ID and network name as their uniqueness. And so it would take a spec update from CNI, but then also we'd want to make sure that the plugins that people would want to use with this specification and multiple attachments also conformed to that CNI spec version. So, I mean, I'm not saying it's impossible, and it's actually not that hard. It's more of a spec and social thing as opposed to a technological one.
Right, but you're saying this will be solved in CNI context, not here, right?
Well, I'm saying it could be solved in CNI context, given that.
No, it's stronger, right? We would, since we're using CNI, it needs to be salt in the CNI context.
Yes, we would like it to be solved in the CNI context. Let's put it that way. So I will take an action item to bring this up again in the next CNI maintainers meeting and talk about that again.
Okay, and just if I think using name is a pretty bad idea. I think we should come up with IDs, right? There should be either UID or other things, because interface name itself implies you're using an interface, right?
Yeah, and as far as I know, I think the interface name is currently required for CNI, even if the plugin doesn't actually care about it.
Sure.
I mean, essentially, if it is required to call add with the interface name, and if that interface name is present, the plugin must honor that name.
Mm.
So effectively, the plugin has to honor that name if it uses interfaces at all.
Right.
So, okay, so I'll bring that up. Doug will update the spec with wording about multiple attachments and interface name uniqueness.
Awesome. Yeah, happy to do that for sure.
All right. Okay, Doug, default networks.
Okay, so yeah, default network. So there's a blurb in the spec that makes sense to me. There's just something I think that maybe we can clarify a little bit, and that blurb has to do with attaching the pod to the cluster-wide default network. So what it says is the meta plugin must always attach the pod to the cluster-wide default network, keeping the existing Kubernetes behavior. This behavior currently consists of selecting the UTF-8 alphabetically first via goes strings.sort method on file names, valid cni.conf or .conf list in etc cni net.d. So, I get the gist of it is we're going to attach to the default network, right? And then we're going to add the sidecars on given what's, put in the annotation. The question that's coming up for me is, well, you're going to have the alphabetically first config name be, I would assume, the meta plugin, so that you have the configuration for the meta plugin, and so that Kubernetes calls the meta plugin, which then delegates to, the other plugins that it would use to create the, multiple network attachments. So, I was thinking that, maybe the just most simplest way to handle this in the spec is to say, since this isn't exactly related to the CRDs, is we could update the wording to say the meta plugin will, have its own method to define what is the default network. And you could just leave it to the meta plugin to define. Otherwise, we could, more strongly suggest it. So, the things that came to mind for me is, the way that Multis does it is it has a way to embed more CNI configurations inside itself. So you can say, hey, here's, your default network, essentially. So, the way that Multis operates today, it says, oh, there's nothing else to attach here, so I'll attach it to, what you specified as essentially the default. In this case, it'll work a little bit differently, that it'll attach to both the default and then to, the additional sidecar networks that you've said I'd like to attach to. So that's one way. Or another thing is we could say pick the next configuration alphabetically after the first. So I was curious what people thought, if we should just word it softly and say it's up to the meta plugin, or if people have a stronger opinion about this and think that there's a way that we should specify this.
I don't mind either, but I just don't want the the next alphabetically next one. Other two are okay.
All right, cool. Yeah, I'm not super hot on that either, because that would just mean always picking the second one.
Yeah, I'm not super hot on it either. However, it does I mean, we've got all the documentation about that. It seems well known that this is how Kubernetes picks networks. I mean, more or less. And the only other suggestion I had was that the networks could go in a different directory. So whatever the meta plugin is would have its own directory for CNI config files, and it would be its own config would be the only one that Kubernetes sees, and then it would look for its network definitions in the other directory. But I don't like that one as much either, because that means that plugins have to know to install their files in some other directory somewhere, and none of them currently do.
I quite like that one in a lot of ways, because what I'm a bit nervous about is if the Multus plugin config file ends up having lots of subsections for all the different networks it needs to know about. That feels a little bit fragile and a little bit complicated as people are adding new plugins to say, well, I've got a new network. That adding a new network process feels like it might get messy. I mean, I think I probably live with everything that's been suggested so far, but my instinct is to try and avoid that.
Can you elaborate on that just a little bit more?
I don't follow what you're trying to say.
Okay, so maybe I've misunderstood what's being proposed, but as I understand it, the Multus plugin has got delegates, and those delegates in it have got the config stored in the actual config for Multus itself, the Multus config file. Is that right, or have I misunderstood how that works?
So yeah, the gist is just that, yeah, the delegates field there is just JSON within that field that defines either a single network or a list of them in the case of Multus as it operates today. So let's just assume, and I guess this is another topic in and of itself, but is the default network likely should be singular, a singular default network. So you'd have this field delegates with just another CNI config packed in there. So in the case that you should change your default network, you would just replace that single file with a new one that has your new embedded CNI config there.
It's one file with a config for every network that Multus knows about. Is that right, or have I misunderstood?
Misunderstood,
in which case I'm going to butt out. But
no, that's all right. Yeah, no worries. So it's the delegates field is a single statically defined network. Otherwise, it uses CRDs as we've specified here. In its own way as it was initially invented, and as I modify it to conform to this specification. So that's it does that. The CRD method here provides for a more flexible and robust way to add, update, and otherwise specify all of the networks that it knows about through CRDs. But as far as a default network, though, the way that Multus was originally written, it just has the delegates field for, in its case, one or more networks that would be used as a kind of default. And maybe I'm not answering your question great. Is that,
no, actually, that was
right?
much that clarified something. I think I got confused about how Multus works. I've used it before, but I'd obviously got a little bit backwards. Right, I think I don't actually mind. I think all of these are plausible options. I'm going to step back and see what everyone else thinks.
Very nice. Thanks, Peter.
I think packing the default config into the Multus config itself seems fairly clean, right? Because then you don't need another file to store all this stuff.
Yeah, that said, if you're running the other plugins as daemon sets, you have no idea really when they're ready. Currently the network readiness scheme that Kube has is it looks for a file and it's cni.net.d, and once it sees that file, it says, oh, hey, the network plugin's ready. So what daemon set based plugins do is they will do their init, do their setup, and then write that file out only when they're actually ready to process network requests. And if you pack the configuration into the Multus config, first you have to have the plugin that you want as the default to somehow either update that, or maybe the readiness wouldn't happen the same way, if that makes any sense.
Right. Yeah, there has to be a readiness check. Yes.
Yeah, how does readiness work with delegates today anyway?
It doesn't know about that at all, but the way that I've worked around it myself is like, say I'm going to do Flannel as a default network, and Flannel, you know, the like suggested way that you deploy it is with a daemon set. And I have just created the daemon set for Flannel, and I've just said, hey, oh yeah, as part of this daemon set, you're going to output this flat config file, and I've just made it Multis's config file. So by the time that Flannel's all ready, it just writes a Multis config file with Flannel packed in it as the default.
That seems
Yeah,
clever, but I feel like that's a little backwards from where we want to go.
Yeah,
But again,
that's a
I
good point.
don't see a great option here with current Cube how to do readiness with Multis, because I'm assuming Multis would write out its config file either immediately, or I don't know, maybe Multis could do its own checks to see if the default network is ready and then write out its config file.
I accept with the Dan's ideas. Like I also had the issue with when I start running some thick plugins like Courier. So I have the same issue which Dan is trying to explain here. Yeah, he's correct on that.
So does Kube change its mind over time about which CNI plugin to use?
If it does, it shouldn't. I think
But readiness
currently,
changes over time.
I don't know. Let me go check that out.
I'm pretty sure that Cube reads that config file on the fly and uses
Yeah, I think it
whatever's
reads it.
alphabetically first, and then just says, "Hey, I'm gonna call this binary."
Yeah, the question is whether it does it once at startup or whether it does it continuously. And it does do it at startup, and it actually also will do it every 30 seconds from the kubelet status loop.
Okay, so it's on a 30-second loop. Okay, interesting.
Yeah, I mean, what that does mean is that if you, let's see, I think, Mike, it does mean that the network can change, which seems kind of wrong.
Well, I think at the end of the day, what we need to have happen is that all the network plugin stack that we want to use is ready before anybody tries to use it.
Yeah, I think that should happen at least for the default network. Because obviously that one has to exist for all pods. For the sidecars, it seems a little hard to figure out when readiness would work there, because you could add those CRD-based ones at any time. And so there's no real way to say, okay, all of our networks are ready, other than the default, which more or less needs to exist before we can do anything.
Okay, this is a pain.
Yeah. I mean, one thing that we could do here is, for now, we could say that the plugin gets to determine its own default network, and that it should not write out the meta plugin should not write out its CNI config file that will be recognized by Kubernetes until that default network is ready. And kind of leave that mechanism up in the air for the moment, and then come back in 2 weeks and try to hammer that out a little bit more, since we're kind of running out of time in this.
Yeah, I like that. I think that it's probably pragmatic to probably say something along the lines of, here's what should be done, and to note it as a further issue for version 2, because I feel like it could bleed a lot if we say, hey, we have to figure out all of this, like what's necessary for readiness, and maybe leave it up to how that installation step is handled, for now.
Doug, could you help me go through that a little bit more slowly, the workaround you said you're doing now?
Yeah, so what I do is, and I'm just using, how Flannel suggests you should install it now, where they give you a daemon set, and inside that daemon set is a CNI config packed into it. and it writes that config out to disk at the right time. So by default, it's just a flannel CNI config, right? So the
Okay, I
kubelet,
understand.
yeah,
Okay,
and I just replace that with a Multis config with flannel packed
Okay.
inside. Yeah.
Right. The trick is that it's something other than CNI readiness that ran your code that created the file that indicates CNI readiness. So that's how it gets untangled. Okay.
All right, I added some notes to the spec and, or not spec, sorry, the agenda, and assigned that task to Doug. So Doug gets to update the spec with some placeholder stuff about the meta plugin handling the defaultness and readiness. Does that work, Doug?
Cool. Yeah, no, that sounds awesome. And yeah, I really appreciated the input on this one because it is, you know, there's a potential for complexity.
Yep.
So appreciate that, everybody, for sure.
All right, let's see, next up, let's see, potential short demo for device plugin for host device CNI plugin integrated with network CRD, and then Corral also has a small topic or a topic about chaining mechanism support. Corral, do you think yours will take a short amount of time?
Yeah,
Maybe 5
mine
minutes?
Yeah. So
Okay. Why
I
don't you
want to
go
discuss.
first?
Yeah. So I just want to discuss like 2 minutes on this chaining mechanism. So I have a use case in which I have to enable the SRV interfaces, and after that, for example, SRV CNI, and then after that, I will create like 2 interfaces of SRV, and then after that, I will invoke the bonding CNI using Multis, and then bonding CNI will use these 2 interfaces and create a link aggregation interfaces. So while in deletion, it should happen in the reverse order. Like the bonding interface should be deleted first, and after that, the SRV CNI should be deleted, and after that, the funnel interface should be selected. But currently in Multis doesn't work in the way like what I suggested right now. The Multis will go for the default network, delete the default network first, and then it goes for the other networks. So this has been a problem. So I made some workaround so that Multis will call Multis. So that issue has been solved. But this particular thing is not captured in the documentation. So I want to make sure that the people understand this. There is a use case around this one. So while deletion, it has to go through the reverse order.
Yeah, the CNI spec for conf lists at least specifies that everything should get torn down in reverse order. But I think what you're talking about is cross chains, or would all of this stuff be in the same chain? Like, would you have one in the same CNI conf list JSON? Would you have SRIO v1, SRIO v2, and then bonding is 3?
Yeah.
Okay. But also Multis currently implements its own conf list sort of chaining support, right?
Yeah.
Okay.
Yeah.
One of the things that I kind of wanted to do or was hopeful about was that the CNI, libCNI code could become flexible enough to actually be used by Multis or CNI Genie instead of having basically rewriting their own code. And that would help as well for injection of parameters because libCNI has its own code for injecting updates in the prev result and things like that. So maybe that's a way to fix this in Multis, is to kind of move over to the libCNI code for network lists.
Okay, I got you. Okay.
It's a thought, and libCNI would be open to PRs or changes to make it more useful from other plugins. And I have actually in the past discussed with other CNI maintainers about having hooks for plugins like Multis or CNI Genie, where they could register to be called in between each plugin invocation in a conf list, which probably would be what you want here as well.
Okay, thank you.
So, all right. So on to Peter. You want to do your short demo?
Yeah, sure. So let me share my screen first. Can you see it?
Yes, we can.
Great. So I want to present alternative solution for the network plumbing again. It follows up the previous bridge plugin I showed, but unlike the bridge plugin, this time it uses the network object, and also it uses CNI on the background. And I hope that this example will make the resource-based solution more clear. So this time I implemented device plugin for host devices, backed by host devices CNI plugin. And the workflow should look like this. First, administrator of cluster specifies networks as network subjects with their name, a resource name which implements this network, and some additional configuration for the device plugin, or maybe even the CNI CNI network configuration. And then still administrator configures these networks on nodes. So in this case, for the host device, each interface is mapped to a network by its alias. So there is an alias selector, and when an interface on the node has this alias set, it will be mapped by device plugin to this network. This is a bit silly and it requires administrator to iterate each node and configure it, but it might as well be replaced by LLDP selector, and then it can get a little bit more interesting. So this is for the administrator part. And then the user, the user uses the annotation way to select networks. So you will say networks and list networks based on the network object names. Then the initializer will come into place. I mean, I used initializer just to hotfire it, but it should be replaced by the admission controller, I think. So this is just for the POC. And what the initializer does, it checks the list of networks, and it looks them up in networks object, and if it finds the network, it will use its resource name as a resource required by the pod. And
so just to be clear really quick, the box you currently have selected and the resources listed there, those are the things that you say, or you said are for the POC with resources?
Yes, yeah.
Okay, so those would not, listing the resources required for the networks in the pod spec would not be a final implementation, correct?
Well, the user specifies the list of networks in the annotation, as is discussed in the multi-network proposal, but on the background, it will be translated to a list of required resources, and it will be placed in a site container or something like that.
Okay, so to be clear, the box on just to the left, where it lists pod, networks, and resources, those resources get added by the admission controller or the initial, correct?
Yeah, correct.
Okay,
yes.
Thanks.
And so this pod will be created on Kubernetes, and it will, I mean, then it will use the resource mechanism to find the node that has these resources available. And that's pretty much it. Now I can try to show the demo. I hope it will work. All right, so first I want to create networks. Network specification looks like this. There is, in the annotation, there is the resource name mapped to the resource provided by the device plugin, and there are some additional configuration. In this case, it's the alias selector. And network blue looks pretty much the same. All right.
And also, to be clear on the alias parts, you're talking about the kernel's alias attribute for an interface, right? So you
yeah, correct.
set like IP link set.
Yeah, that's what I need to do now.
Thanks.
Just a note on that. So the reason for the alias was that an admin now choose, we don't depend on the device name because we expect a heterogeneous cluster. So an admin could, in theory, go through the cluster to the nodes and set an alias on all the appropriate devices independent of the device name. Further down the line, that could also be automated. The point here is that we're using CNI in this device plugin to achieve all this.
On my Minikube instance, I created 3 additional links, th2, 3, and 4. And now I can set the matching aliases for the alias selector. So we have ETH2 for network red.
See. Oh, there we go.
And ETH4 will be connected to the network blue. And this decision must be done by administrator of the cluster, or eventually by LLDP. And now the device plugin should so device plugin looks for the network objects and for links available on the node. And once there is a matching interface, it will expose it in the node available resources. Let me check if it works. Okay, so there are allocatable resources. For network blue, there is 1 interface. For network red, there are 2. And now I have a pod that I will create. In its annotation, it says that it wants connection to network red and blue. I had some troubles with the initializer, so there is a little hack that I add a list of initializers manually. It should be done by Kubernetes, and these 3 lines shouldn't be there. So try to ignore it. And now when I create the pod, so it's really out of 2 because there is the container I just created and additional container added by the initializer. And it does not work. Let me check why.
Oh, it might just work in a second because he...
Yeah, it's trying again.
Oh yeah, it's running down, thanks. And so let's look at, let me show you the actual pod that was created. So there should be an extra container. Yeah. So in this block, there is the extra container, and right now it's visible, although it could be just a Scratch container that has no OS running in it, and there's a silly sleep for a very long time. But this should be something reasonable, and it has resources we requested in the annotation here. And when I go to the pod, it has ETH2 and 4 moved out of the host into this namespace. It keeps the name of the original name of the interface. I have no good idea how to name them, but this could be simply changed. And that's it. So I just wanted to show that the whole picture with network objects involved and the CNI on the background.
Okay.
Any questions?
So the DB itself will take care of the network connection. So this right? You
Say
mean the
again,
device?
please.
So the device plugin itself will take care of the network connection.
Yes, yeah.
So it will bypass the CNI.
No, the CNI is executed by the device plugin upon allocation.
Okay, so it will call the CNI binary, the device plugin. So because
Yes.
okay.
So the plugin is effectively, the device plugin is effectively shipping the CNI binaries or libraries, however you call them, and is calling them. So it's not the CNI instance of the kubelet or close to the kubelet, but rather a duplicate inside the device plugin.
So you mean to say the code is duplicated inside the device plugin, the creation of the network? I was just going through the document. So in the document, it has been mentioned that the device plugin API will not directly allow any CNI plugin to be used within the DB. So I was trying to understand this one, the relationship to CNI. So
in this case, it's just when there is an allocate call, we track the container that is supposed to be allocated or created, and when it is created, we just execute this CNI with the, and also the CNI network configuration is inside the device plugin.
okay. So that I have another question. So the device plugin will be invoked before the sandbox creation, right?
What do you mean by the sandbox?
You mean the infra container, the container which has the network namespace?
Yeah, so the device plugin runs it runs the whole time, and the allocate call is active. We get the allocation request before the network namespace is available, so we keep track of it.
Oh, you keep the track of that. Okay.
Yeah, at the moment it's like still a hack, but we work with the resource management group, and we hope that there will be a better API for this case eventually.
Okay, so in the deallocation, how you do this deallocation method? So the one gap I find it in the device plugin is it has the allocation, but it don't have the deallocation. So how are you filling that gap?
Yeah, so we still hope that even the deallocation will be added to the device plugin API, but at the moment, I mean, upon the allocate call, we keep the allocation request inside the device plugin, and we monitor the container as well. So once the container disappears, we call the allocate. But it's implemented by us. It's not provided by the device plugin API.
Okay, so when the pod is get deleted, so you will keep track of the pod which is getting deleted, and you will delete the interface, right?
Yeah, we will move it back to the host network namespace.
Okay. Thank you.
Welcome.
Actually, just a note, one important point of this POCing is to understand what device plugin changes are needed in order to better support network device plugins. So like what you meant, the deallocation is one point, and also the timing about the sandbox.
So that was the main concern about me when I look into the device plugin. I was at the same question actually. One is the deallocation and the sandbox actually. So, but there was another proposal. I don't know if you guys seen. There is some guy called Vikas. So he mentioned like 2-in-1 device plugin, which does both CNI and also the device plugin. So is that the same proposal or it's a different proposal actually?
Yeah, we work with Vikas, and it follows pretty much the same idea he had.
Okay.
There is, if I understand correctly, there's actually one difference. So in Vikas' proposal, we would provide enough information to the DP to use CNI as it's used today, so to provide the pod informations and I think the pod informations to the device plugin. And then the DTP would do everything like the allocation as well. In our proposal, leave the allocation, so the moving of the interface, to the kubelet or to the DP part.
Mm-hmm. I was comparing these two proposals. So in the Vikas proposal, what was promising for me is like the CNI is involved. So there is no need for the deallocation, because when the pod is get deleted, the CNI will be invoked. So it will do this deallocation if I'm using any SRIB based or the DPTK based thing. I can reallocate it using the CNI itself. So I was trying to understand these both proposal before actually. So thanks.
All right, thanks guys. We are also out of time, although Jeremy, if you're still on, if you want to do 30 seconds about your item.
I just wanted to call attention to the finalized agenda we have for resource management, and folks like Fabian and Peter have put together some of the content for that. There's several other documents floating around. I've pasted in part of the things that I think this group would also be interested in. Peter, I don't know if you looked at the latest document called Representing Compute Resources in Kubernetes. That was something we briefly talked about on a scheduling call earlier today. That's a pretty intense and elaborate document. That's probably the key one for us to know about over the next couple of weeks. But anyway, these are the topics that we're going to hash out at the end of March, 2 weeks from today. The reason these are in Google Doc format is because we want 2 weeks of review from as many people as possible. So I'm going around to different SIGs telling them that these exist. And please review and save us some effort and bike shedding and whatnot. Would be much appreciated. So that's it.
All right, thanks, Jeremy. And unless anybody else has anything really quick, we are done with the meeting. Going once, going twice. All right, see everybody in 2 weeks.
All right, thank you guys.
Bye.
Bye.
Bye.